Okay, so the first thing I want you to do is to get out your textbook and turn to page 572. And I want you to look at number 1. And I want you to go ahead and complete A, B, C, and D. As you complete those, you should find a pattern as you go, making it easier for you to answer them. So go ahead and pause the video and complete all of A. Okay, so take a moment and check your answers here on A. We should have found a pattern as you went. We should have noticed that all our binomials have x and the constants are the same number. The only thing changing are the signs. We have a minus plus, a plus plus, and a minus minus. And then you should notice that there is a pattern or the same thing is happening for each one of these types of situations. So looking at number 2 down here, it says, what patterns do you notice between the factors and the products? So let's just look at this first set. When we have a minus plus, we should notice that right here on each one of these, the middle term cancels out, okay? So when I'm answering this question, I can say there's 3 types of problems, so we should have 3 answers here for number 2. So we could say when the variable and the constant are the same, but the signs are different, the middle term will cancel or zero out. And then we should notice too that the x squared and then the 4 times 4, that's a perfect square, which is 16. So now I want you to take a moment and write the rule for when the variables are and the constants are the same and they both have a plus sign, and what the rule is when they both have a negative sign. So pause the video and complete the 2 other rules here. All right, so let's look at number 8 together. You should notice that 25 is a perfect square. 5 times 5 is 25. And so this is going to be called a perfect square binomial. We should also notice that they're both plus, as we have up here, plus plus. So using this rule here and here, we really shouldn't have to do any work. We should just know that this binomial is going to be x plus 5 times x plus 5. Because 5 times 5 is 5 squared. Then we'll have 5x and 5x, which gives you 10x, and x times x is x squared. Okay? And then let's look at b. b is also very similar to up here, where our first term has a variable or coefficient, excuse me. Here we're used to trinomials with a coefficient of 1, and here we have a coefficient of 4. So again, I'm going to set up my parentheses here. And I know the first 2 in here have to multiply to the 4x squared. So I should know that that's going to be 2x times 2x. 2x times 2x is x squared. I should also notice these are both pluses, so these both have to be pluses. And then again, 25 is a perfect square. And so that's the only factors are going to be 5 and 5 and 25 and 1. So again, this is going to have to be 5 and 5. And again, if I want to do a quick check, 5 times 2 is 10x, and then this is going to give you 10x, which will give you the 20x as the center term. Okay. Then when we get over to C here, we have a minus plus, which we learned our rule up here. When you have a minus plus like that, or that's a different kind, sorry. That's a different kind because we don't have the factor, we're factoring it. Okay. So again, here we have a perfect square. Should know that 12 times 12 is that. So again, we're just going to set up our parentheses. And we have x squared here, so we know that x is going to go here, and x is going to go here. 144, we know that's going to be 12 times 12. And then you need to look at the signs. we have a minus here and a plus here. So it has to multiply to a positive but add to a negative. And the only thing that can do that is two negatives, a negative times a negative. So we have negative 12 times negative 12, that's positive 144. And then negative 12x plus negative 12x will give you negative 24x. Okay, so go ahead and see if you can figure out D on your own. Pause the video, figure out D. And then come back and we'll look at E. So we look at E, there's no middle term. We have the A and we have the C. And when we go up here to where there had no middle terms, it had no middle terms when this was minus. We had a minus and a plus. And so if we think about this, the only thing that can multiply to 25 would be 5 times 5. And we only can have two negatives or two positives in the center. If we try it, we could have x plus 5 times x plus 5. But the problem with that is we'll get the x squared, we'll get the 25, but here we have 5x and 5x. This would give us a 10x. So that can't work. The other scenario would be to be x minus 5 and x minus 5, because negative 5 times negative 5 is a positive 25. However, this will give us center terms because it has two negatives. The only time we're going to not have a middle term is if it's a minus plus. So again, if I multiplied this out, I'd get negative 5x, and negative 5x would give me a middle term of negative 10x. So this one we just say is not factorable. This is impossible to factor. So we just say not factorable. Okay. Now let's look over to F. Okay. F, I notice that again, this is a perfect square here. 16 is a perfect square. 1 is also a perfect square because 1 times 1 is 1. So let's set up some parentheses and see if we can figure this out. And that's also an x to the fourth. So we have to think about, first of all, what two numbers multiply to 16? It's going to be 4 and 4. Now if I put my x here, x times x is x squared. But I need it to be x to the fourth. So hopefully you know that we're going to put a 2 here. X squared and x squared, you add those exponents for x to the fourth when you multiply. Now there's no middle term and it has a negative, so we're good there. So we can do plus and then minus and then put 1 times 1 is negative 1. And again, you can check it out. When you multiply these two, you'll get 4x squared. When you multiply these two, you'll get negative 4x squared, which will cross those out. Okay. And then 10, we're looking at zeros again. And so we're going to do the same thing as we did prior, but we're going to set them equal to 0. So again, when I look at 10, I should notice that's a perfect square, and that's a perfect square. So this is a perfect square trinomial. So very simply, I just have to think what times what is 25x squared, and that's going to be 5x and 5x. And then I look at my signs. These are plus plus, so this is going to be plus plus. And then I have 4, which is a perfect square because 2 times 2 is 4. So we're going to have 5x plus 2. And then we're going to write that simplified by writing that 5x plus 2 squared, because it's the same thing times the same thing. Just times x is x squared, or 5 times 5 is 5 squared. That's going to give you the same thing. But again, if we want to find the zeros, all we have to do, because these are the same, is we have to set it equal to 0. So we have 5x plus 2 equals 0. Subtract the 2 over. So that's going to give me 5x equals negative 2. And then we divide by 5 and 5. And so the root, or the x-intercept, is going to be negative 2/5. And because these are the same, it's only going to have one root. It's only going to touch the x-axis at negative 2/5. So if we think about it, if I put my quadratic equation into my y equals, I could either put the standard form method in, Or I could put my new method in here, my f of x equals 5x plus 2 squared. If I put that in and I graph it, you'll see that it only touches the x-axis in one spot. It just barely touches here at the minimum. And so that's why it only has one root, because it's just touching in one place right here. All right, so if we look at this, I want you to finish B, C, and D on your own. Be careful. Look at this one and compare it to the one up top we just did. That one's a funny one. And this is how I feel about Michigan losing to Louisville last night. Sore loser.